You know, we've only ever had one home, this incredible, fragile, beautiful blue marble. But as the pressures start to build up here on Earth, humanity is looking to the stars and asking this huge question: is our future somewhere out there? Today, we're going to embark on one of the most ambitious quests we've ever dreamed of: the search for Planet B.
And look, this isn't just sci-fi stuff anymore. With our technology leaping forward, the question is getting more and more real. So, are we really about to become a multi-planetary species? Well, as we're about to see, every single potential new home comes with these extreme, almost impossible challenges. So where do we even begin?
Okay, so our journey kicks off right next door, the moon. It's our cosmic proving ground, just a quick 3-day trip away. The best way to think about it is like the base camp for climbing Mount Everest. This is where we test out our gear, our strategies, and the absolute limits of human endurance before we even think about the marathon missions ahead.
Now, the secret to surviving on the moon isn't just about what we bring with us, it's about what we can find when we get there. This slide breaks down a total game changer of a concept called ISRU, or In Situ Resource Utilization. Basically, it means living off the land. We could mine water ice to get breathable oxygen and, get this, rocket fuel. We can even use the lunar soil, the regolith, to 3D print buildings. This turns the moon into a cosmic gas station and a hardware store, all in one, which would save us a fortune by not having to launch everything from Earth. But here's the thing. The moon has this really dangerous secret. This number, -1%, that's how much bone density an astronaut loses per month. It is a staggering rate of decay. In the moon's low gravity, your own body literally starts to dissolve itself. And this is the first huge hurdle we face. Our biology is perfectly, and I mean perfectly, tuned for Earth and only for Earth.
And it's not just our bodies that would take a hit, it's our minds. This quote from Neil Stephenson just captures the psychological cost perfectly. I mean, just imagine it. You're in a tiny, confined space. There's constant danger. You're completely isolated. And you're surrounded by an endless, unchanging landscape of gray dust. A lunar colony might feel less like a brand new home and more like a high-tech prison. Keeping our minds in one piece could be just as hard as keeping our bodies alive.
Which brings us to, well, the main character in our whole story, Mars. For centuries, the red planet has been our great red hope. It's got an atmosphere, a day that's about 24 hours long, it even has seasons. On the surface, it feels so tantalizingly close to being a true Planet B.
But, and this is a big but, once you start looking at the details here, that dream starts to crack. The gravity is only about 38% of Earth's, so yeah, bone loss is still a massive problem. The atmospheric pressure is so low it would literally boil the fluids inside your body. And just look at that last line, radiation shielding. See, Earth has this strong magnetic field that acts like a force field, protecting us from deadly solar radiation. Mars does not. And that missing shield, well, that leads us to this terrifying number, 0.66 sieverts. That is the devastating dose of radiation an astronaut would soak up on just one round trip to Mars. That's more than the entire career limit for an astronaut. On the surface, you're just constantly being bombarded by cosmic rays. Really, the only way to survive there long-term would be to live like a mole, in shielded cities built deep underground. Okay, so Mars is trying to kill you. But for all its hostility, it also gives us a chance to be incredibly clever. This process you see here, that is literally the recipe for making rocket fuel on Mars. NASA's MOXIE experiment has already proven this can be done. You just grab CO2 from the thin Martian air, you split it into oxygen, and you use that to create methane fuel for the ride home. This is the absolute key to making a Mars colony truly self-sustaining. So, the moon is tough, and Mars is basically a radiation-soaked freezer. What if we've been looking in all the wrong places? It's time to get creative and explore some of the wildcard candidates for a new human home. And trust me, things are about to get weird. Welcome to Venus, often called Earth's evil twin. The surface, as you can see, is a total hellscape. It's hot enough to melt lead. But get this, here's the crazy paradox. If you travel about 50 kilometers up into its thick atmosphere, you find the most Earth-like conditions anywhere in the solar system. The pressure is normal. The temperature is, frankly, pretty pleasant. It's an absolutely stunning realization.
So you're probably asking, how on Earth or Venus would we actually live there? Well, with this brilliant idea called HAVOC, massive floating cloud cities. And here is the genius part. In the super dense CO2 atmosphere of Venus, our normal, breathable air, the stuff we're breathing right now, it acts as a lifting gas, just like helium does in a balloon on Earth. So the very air you need to survive inside the habitat is what keeps the whole thing afloat. You'd have almost normal gravity and perfect radiation shielding from all that atmosphere above you. How cool is that? All right, for our next wild card, we're heading way out there, to Saturn's biggest moon, Titan. This place is truly alien. It has an atmosphere so thick you could walk around without a pressure suit, though, you'd still need an oxygen mask and a very, very warm coat. It's also the only other place in the universe we know of with stable liquid just sitting on its surface. Now, those aren't lakes of water, they're lakes of liquid methane. A bizarre, freezing cold, but absolutely fascinating possibility. Okay, so up until now, we've been talking about colonizing other worlds. But what if the ultimate answer isn't to find a new home, but to build one from scratch? This is it, the final frontier, building entire worlds out in the vacuum of space. What you're looking at is a concept for an O'Neill cylinder. It's a gigantic space station, we're talking miles long, that's constantly rotating. And that rotation creates a centrifugal force that perfectly mimics Earth's gravity on the inside surface. This completely solves the bone loss and all the other nasty health problems that come from living in low gravity. You could literally have cities, forests, and rivers, all inside a world that you built yourself, using materials you mined from asteroids nearby. Now the ultimate dream, right? The big one, is heading to other stars. The nearest potentially habitable exoplanet we know of is Proxima Centauri b. But this timeline just shows you the mind-boggling scale we're dealing with. With our fastest current technology, it would take us around 73,000 years to get there. That is longer than all of recorded human history. Traveling between the stars isn't just an engineering problem, it's a fundamental problem of physics and time itself. So when you look at a roadmap like this, you realize this isn't something we'll see finished. Becoming a multi-planetary species is a multi-generational project. Right now, we're in phase 2, heading back to the moon, sending our first cruise to Mars. Maybe in the second half of this century, we'll see those industrial bases using ISRU. But full-scale colonization, reaching for the stars, those are dreams we're dreaming for our children's children. It's a true testament to long-term human vision. So we've toured the solar system. We've gone from our closest neighbor to some of the strangest, most distant worlds imaginable. We've dreamed of cloud cities on Venus and voyages to other stars. But after all of that, our journey brings us right back home to one single inescapable conclusion. Let's be real for a second. The hard truth is that every single one of these other options is brutally, relentlessly hostile to life as we know it. To survive on the moon or Mars, we'd have to live like moles, buried deep underground just to escape radiation. To live on Venus, we'd have to float in giant balloons above clouds of sulfuric acid. Every single option requires technological life support on a planetary scale, just to create a pale imitation of what Earth gives us, effortlessly for free. And that right there is the ultimate takeaway from this whole journey. The search for Planet B teaches us that the most valuable, the most advanced, and the most miraculous world we will ever know is the one we're on right now. It is a self-regulating, self-repairing life support system of breathtaking complexity, and it doesn't just support us, but millions of other species too. The quest for a new home is a noble one for sure, but it can never distract us from our most urgent and critical mission of all, protecting this one. Thank you so much for spending your time learning with us today. If you found this insightful, please hit that like button, drop a comment with which potential Planet B surprised you the most, and be sure to subscribe to Info Now for more deep dives into our world and beyond.